Hey, hello everyone. Welcome to the second video of the CloudFormation deep dive series. In this video, I'm planning to talk about how CloudFormation works in general. I think this will be helpful when you're designing your stacks or working with CDK in general. So let's get started. I have a couple of sample templates in my local. Yep. So this is a pretty simple template. You can see that I've defined an S3 bucket and a security group. So first, I'll walk you through how CloudFormation is going to pass this template and what happens behind the scenes. So during the initial stage, when you're creating a stack, CloudFormation is going to pass your template. It's trying to find out what all resources you've defined in your stack. So in this case, I actually have a S3 bucket and a security group defined. Now, CloudFormation is not one giant service which handles all the operations on its own. So behind the scenes, what it's going to do is like it has resource handlers for each resources defined. So in this case, like for S3 bucket, there is a set of handlers defined. So these handlers are actually Lambda functions deployed in the service teams account. And for EC2 security group also, there will be a set of handlers. Like there will be a handler for create, there will be a handler for update, list, read, and everything. So when you deploy this stack, so it's going to first find the resource, like what all resources are defined, and then it's going to extract the resource properties. So once it has the resource and its properties, it's going to invoke the specific handlers. So during the first time when you create the stack, it's going to invoke the create handler for S3 bucket as well as the security group. Now inside the handlers, anyway, like to create a resource in AWS, like from CLI or console, like wherever you create this, like it's going to be an API call at the end of the day. So for the S3 bucket, the handler would actually perform a create bucket API call. And for the security group, like it'll perform a create security group API call. And while doing so, it will get these properties that you've added in your stack, and then it'll pass on to the create request. That's what happening behind the scenes. Once the creation is complete, CloudFormation will store the state of your template in its system. And CloudFormation doesn't store the state of your resource at all. So I'll show you how like this would affect in your day-to-day workflow. Now we'll go to the console. Yep. This is the stack that I've deployed. You can see that there are two resources defined in this. One is the security group and another one is the S3 bucket. Let's go ahead and delete the security group. Okay, delete security groups. Yep, security group is deleted. Now if I check the stack drift, let's see the results. You can see that the resource security group is deleted. Now let's go back to our template. Yeah, let's go back to our terminal and let's try updating this stack with the same template. So I haven't made any changes to the stacks template. It is as is, and I'll do update stack with the same stack name. Yep. We got an error saying that there are no updates to be performed. I'll tell you why this happened. So CloudFormation is going to compare your previous template with the current template that you have provided. So if it does a diff between these two templates, it's not going to find any differences at all. That's why you're getting this validation error. So like I said, CloudFormation works by comparing the state of your template and not your resources. So how do you get out of this drift? We'll take a look into that. And before that, we'll go into how updates would work. Um, now that we have the resource deleted, we'll try to update this deleted resource itself. So I'll change the port and then update the stack. Yeah. Now this update went through, which is because CloudFormation saw that there is a change or diff in this security group resource. And now what it'll do, it'll get the new properties of this and then it'll pass to the security group handlers. So when the handler is invoked, the security group handler would actually try to update the resource, but during that time, it's going to fail saying that the resource does not exist. So that's what's happening in the stack as we speak. Switch to the AWS console. Right. So the update got initiated, the update failed. Then it started to roll back, but rollback also failed. So I'll tell you why this happened. The rollback also failed. During the rollback, CloudFormation would try to revert to the previous state of the template, not your resources. It's going to revert to the previous state of the template. So the previous state of your template was this. This was the previous state of your template. Let's switch to VS Code. Yep. So this was the previous state of your template. So we modified to 81, but the previous state was 80. So what CloudFormation does during the rollback is that when an update fails, it'll get the previous template from your that it has stored, and then it'll try to do another update. So that's what's happening here in the console. So during the update, it failed because the resource does not exist. During the rollback, it tried to revert back to the previous state, which is 80. So this is the previous state that you see in the template screen, but that also failed because we have already deleted the resource, and we now have the stack in update rollback fail state. So if the update fails and the rollback also fails, you'll get into this state. And to remediate this, there's only one option. We'll have to continue the rollback. And for this particular drift, there's nothing that we can do. So we'll skip this resource, then continue the rollback. Yep. So we now have the stack in update rollback complete state. So let's go back to the VS Code. So to remediate this kind of drift, there's no other way apart from commenting this resource out and then removing from the stack. So we'll comment this, update the stack, put it back, and then update the stack. That time we'll be able to recreate this resource. So that's how we get out of this particular drift. There's no other way apart from commenting this resource, because if we try to update the stack again and again, either it will throw a validation error that there's no updates to be performed, or you'll get an error that the resource is already deleted. So it's going to be either of these two things. Now let's try commenting this, and I'll update the stack. Let's go to the console. So delete in progress. Now the stack is update complete. We only have one resource. I'll quickly flip this back. Okay, we've uncommented, then we'll perform one more update. So this should hopefully bring the resource back. So we'll refresh. Right. Now the resource is being recreated now. So we have remediated this drift. So we've talked about drift. We saw how drift is remediated for the case of deletions. But what about others? Like if you modify the resource out of the band, but and the resource still exists. The answer is it depends on the resource and the API behavior. For example, um, for the case of a Lambda function, say you update the runtime of the function outside of CloudFormation. Um, the API call, the update function API call would actually won't mind if you do the same runtime upgrade again. What I mean is that say you update to 3.10, Python 3.10 outside of the CloudFormation stack, and in your template, it's still 3.19. You update the template to 3.10 and then do a stack update. There will be a update function API call. This API call would see that the Lambda function is already on 3.10. It'll never mind, like it'll just send back a success, and you have the stack in a update complete state. That's it. But at the same time, take the case of a open search cluster. Say you have 1.x in your template. You go outside of CloudFormation and then you update it to 2.x. And then you update the same thing in your template, like 2.x, and then you try to update the stack. That time you'll get an error saying that the version is already 2.x and it's a conflict. So that's why I say that it depends on the resource and it depends on how the API is going to behave. Most of the time, we would be able to fix this by reverting the drift itself. Say if it's some kind of tag that was updated out of the band, you could put it back and then make the changes via the template and then update the stack to have the desired configuration. But if things like open search cluster are not working out for you, the only option you have left is by importing. So how you do that is like you'll comment the resource by adding a deletion policy of retain. So that won't delete the actual resource but remove it from the stack. and then you put it back and do a import operation. So you have, uh, let's refresh this. Yeah, import resources into stack. So you can do this to bring the resource back into the stack. So that's how you remediate drifts. Much of the things that you see in CDK and SAM are basically due to how CloudFormation works. For example, if you refer to an asset for your Lambda functions code, say you point that to a folder in CDK or SAM, like during the build process, this code would actually be zipped and a hash would be generated based on the source code. And this hash is referred in the template. So this is because during the update, if there is a failure, it can always refer back to the previous hash that's already there in the S3 bucket. But take the case that you're maintaining the source code in a single key. That is, like in the S3 bucket, you have a static key as lambda handler.zip. Then you're updating the same file every time during the updates. The risk with this is that if there is a failure, CloudFormation would actually use the previous template and then try to do an update, right? So in your previous template also, you have the same key. So this same code, this same bad code would be reused again and again, and you'll be basically in a loop trying to get out. This is the reason why CDK and SAM is actually appending a hash to the function source code so that like the rollbacks are easier for the users. And there's also one more feature in SAM where it creates or generates a version even if there's no updates to the resource actual function code, right? So this is using the logical ID. Like CloudFormation would link the logical ID to the resource that you are actually trying to create. So this instance security group, if I change this security group to security group 2, CloudFormation will think that you've actually removed the security group, and then you're adding a new one. So it'll create the new one, and then during the cleanup phase, it's going to delete the previous one. So essentially, you'll have a replacement. So what the SAM auto publish alias does, or auto create version does, is that every time you do an update, it'll manipulate this logical ID, essentially forcing to create a new version every time. So that's how it works. So in this video, we saw how CloudFormation handles creates, updates, and the update rollbacks, and what happens behind the scenes. We also saw about how what is a drift and how to remediate them. Um, that's all for this video. I'll see you guys in the next one. Thanks a lot for watching. Do subscribe to the channel. Thank you. Bye.